This lesson is all about representing linear functions within real-world contexts. And let's look first at how it connects to STAR. So we've got a couple of standards we're looking at. One is A3A, where students determine slope from multiple representations. So here they have to find the slope from a table. And another is A3C, where they look at key characteristics of graphs of linear functions. So the zero, which is the x-intercept, the y-intercept, and the slope. This is a pretty straightforward lesson. It has success criteria and objectives in addition to a process standard and a STAR warm-up. For this first getting started activity, I've given the kids a hint to let them know how many of these are linear, how many are nonlinear, and how many are not functions. If you don't want them to have that hint, just make your own copy and delete it. The next slide here talks about input values and whether or not they're consecutive. So here's an example of consecutive input values, and here's an example of non-consecutive input values. We're just trying to draw their attention to it so that they understand when I'm trying to decide is something linear, I need to look for a constant rate of change. Here's some practice. Here are some more contextual practice opportunities with pretzels, a visit to the fair, and a fish tank, and then a check for understanding. As we move on, we start to work on this scenario that's going to continue throughout the lesson. In this example, Marilyn is selling t-shirts. And what does this graph mean? It means if she sells 0 t-shirts, she makes $0. And then the graph shows her profit, shows her earnings. Students explore how much she would earn for selling different numbers of t-shirts. And one thing to point out here, she cannot sell 2.75 t-shirts. In reality, the graph of this really should be a discrete function, right? And that's what this example right here is trying to point out. As we move into day 2, we add some complexity to this scenario by saying, well, what if Marilyn were to give away some t-shirts? How would that change the graph? So if she gave away 3 t-shirts, she would need to sell 3 t-shirts before she broke even. And that's what we see on the graph here. And this gets students to start thinking about the meaning of the x-intercept of the graph. In fact, we look at linear functions in a different form here, in factored form. So here we have the factored form, g of t equals 15 multiplied by t minus 3. And students realize that that's the same as the general form, g of t equals 15t minus 45. They're the same function, but the different representations tell us different things. On this one, it's easy to see that Marilyn needs to sell 3 t-shirts before she breaks even. That's the 0 of the function. This form shows us that if she doesn't sell any t-shirts at all, she's going to lose $45. That's also useful information. So looking at the y-intercept has different utility than looking at the x-intercept. And that's one thing that we want kids to see here. So this concept is connected to the idea of a polynomial and how those are classified and what it means for polynomials to have a degree. And then we look at just one more variation of this scenario. What would happen if Marilyn were to have a booth fee of $35? How would that change the function? And of course, it's going to shift it down 35 more. We are not using the formal language of transformations of linear functions, but the kids are beginning to get the idea of how that's going to work. Our talk, the talk, has students determining whether they could always, sometimes, or never get an approximate value or an exact value. You want to be sure that kids have a clear understanding of the difference between approximate and exact. And they may work on the talk with their partners. At the end here, they're going to complete a graphic organizer that looks at the general form and the factored form within multiple representations.